All right, this is the topic 8, part 2 quadratic study guide. So here we go. So with number 1, we have a quadratic written in standard form. So we have x squared plus 6x plus 9. This is standard form. There's only 2 forms with quadratics, and we're dealing with standard at this time. But it doesn't really matter what form you're in when asked the questions that you have for question 1. The first one, which is the y-intercept. For the y-intercept, we know that the x value has to equal 0. So if we take our equation and we put zeros in for the x's, we have 0 squared plus 6 times 0 plus 9, which gives us y equals 0 plus 0 plus 9, which gives us y equals 9. So within 20 seconds, we have our first answer, which is 0, 9 for our y-intercept. For our second problem, they ask us for, or I ask you for, the x-intercept. Well, we know for that the x-intercept that the y value has to always equal 0. So we have 0 equals x squared plus 6x plus 9. So at this time, we have to solve for x. So as we've been talking about in class, we have x squareds and x's, which means we have a mix of variables. When you have a mix of variables, you have to factor the equation. So this is set up for a diamond, which is by all means fine. What adds to give you 6 but multiplies to give you 9. But if we want to be more efficient with it, we realize that this is a perfect square trinomial, which means that the first term is a perfect square, the last term is a perfect square, and the middle is double the perfect squares multiplied. So if we were to take the square root of x squared, which is x, square root of 9, which is 3. If you take x and 3 and multiply them, and then you were to double it, you get the middle. So not that you have to do that, but it's something to know later down the road. So we have 0 equals x plus 3 squared. So what we're saying now is, if you multiply to get an answer of 0, you needed to multiply with a 0, which means x plus 3 had to equal 0. So what would x need to be to give you a 0? Well, x would have to be a negative 3. So we have our x-intercept of negative 3, 0. Now we go to part C, the vertex. Well, the vertex is given by the formula negative b over 2a. And remember, when we're in standard form, it's ax squared plus bx plus c, where a, b, and c are the coefficients, or the numbers in front of the variable. Except for c, because there's no variable here, so c is just whatever number you see. So we have x squared plus 6x plus 9, which means in our, excuse me again for my voice, which means in our formula, the a value is 1, the b value is 6, and the c value is 9. So if we're going to do negative b over 2a, we're going to take b, which is a 6, but we're going to turn it into its negative, which is negative 6 over 2 times a, which is a 1, which is in front. So negative 6 over 2 gives you a negative 3. Now vertex ends in an x, which means the x value is what you get from the vertex formula. So we now know that the x value is equal to a negative 3. But we know that a point isn't made up of just a x. It's a x and a y. So if the x is -3, now we need the y. Well, how do we get a y? Well, anytime we have the x value, we just plug it into an equation to get the y value. And again, our equation is y equals x squared plus 6x plus 9. So let's take our -3 and let's plug it in here. So we have y equals x, which we now know is -3, so -3 squared, plus 6 times x, which is -3, plus 9. So -3 times -3 is 9. 6 times -3 is -18, plus 9, which is what we've got at the end. 9 take away 18 is -9. -9 plus 9 is 0. So we now know that the y value has to be 0. So your vertex is located at -3, 0. The last question is, does it open up or open down? And this just comes from the general idea of what happens with quadratics. When you have y equals ax squared plus bx plus c, which is standard form, if the a is a positive, it makes a smiley face, which means you open up. If the a value, the number in front, is a negative, then you open down, which we got a frowny face. So in this term, we have an x squared. Well, the number in front is a 1. Well, that 1 is a positive number, so therefore it's going to open up because it's happy. So 1D is going to be up. All right, on to question 2. Now this is just a vocabulary question. It says, what other names are there for the x-intercepts? So this is just pretty much memorization, which unfortunately is just something that you have to do in math every once in a while. So x-intercepts are also known as the roots, the zeros, what we also call the solutions to a graph. So all 4 of these are synonyms for each other when we're talking about quadratics themselves. Now for number 3, I'm going to make a very quick sketch. You got something looking like that. And they ask you to pick all of the ones that apply, meaning which all of the ones are true. So number 1 says the graph has a y-intercept at 0, 5. Well, 0, 5 would be somewhere up here. That's definitely not true. So we're not going to pick option 1. Option 2 says it has a max at -3, 4. Well, remember, max means the highest point on a graph. So the highest point on the graph is going to be somewhere up here. And if you look at your picture, it actually is located at -3, 4. So we're going to pick option 2. Option 3 says it has an x-intercept at 1, 0. Well, if you look, 1 is right here. It definitely doesn't touch 1, so we're not going to pick that one. The next one says it has a y-axis line of symmetry, which we also call the axis of symmetry. Well, if you were to cut, axis of symmetry is where you can cut it down the middle. If we were to cut this right down the middle, we are not cutting it down the middle on the y-axis. We're cutting it down the middle at the x value of -3. So we're not picking that option as well. The next one says that you have zeros, which remember, zeros are also known as x-intercepts at x equals -5 and x equals -1. And if you look closely at your graph, and obviously my graph is not perfect, but it is at -5 and -1. So we're going to pick that option. And the last one's super simple. They give you an equation, y equals x squared. I don't even care what the rest of it says. Because remember, if the number in front of this x squared is a positive, that means your graph has to be a smiley face. Well, our graph, obviously, if you look on your study guide, is a frowny face, which means it can't have come from an equation that has a positive in front of the x squared. So therefore, only the second and the fifth option work. On to our second page. For this one, which is number 4, you have the equation y equals x minus 3 squared minus 4. Now this looks different compared to the one that we had just worked on a second ago with the ax squared plus bx plus c and your x squared plus 6x plus 9. That's standard form. What we have now is what we call vertex form, which is y equals a x minus h squared plus k. And the great thing about this is if you did well with the absolute value unit, it's the exact same thing. Y equals a x minus h plus k, except we put parentheses in instead of absolute value bars, and we put it squared. But the vertex is still the same formula, h comma k. So when I look at this, the vertex, see how there is a minus sign in both formulas? That means you use the opposite of what you're looking at. So I see a -3, so I'm going to use the opposite of -3, which is 3. There is a plus sign in front of the k value, which means I use exactly what I see. So I see a -4, that means I use a -4, which means we've answered part A, which asks us for the vertex, which is 3, -4. Now for B, they want the y-intercept. Well, remember, just from like the first page, the y-intercept means the x has to equal 0. So you take your equation, you take the x out, and you put a 0 in. So if we do the order of operations, 0 minus 3 is -3. -3 times -3 is 9. And 9 minus 4 is equal to 5. So we have our y-intercept, 0, 5. Now, C asks us for the x-intercept. Well, for the x-intercept, we know that the y has to equal 0. So we make our equation equal to 0. So 0 equals x minus 3 squared minus 4. So okay, so let's not get ahead of ourselves here. So we're solving for x. So now that we've been in the quadratic section, we always ask ourselves, are we mixing x's or is there no mix? I just have an x only, so that means no mix. If there's no mix, that means there is no factoring. So we get to play the game of opposites. So how do you get rid of a -4? Well, you add 4. Okay? Now, how do you undo squaring something? Well, the opposite of squaring is to take the square root. They cancel each other out. So we take the square root of the other side. So we have x minus 3. And normally, when you learned in middle school or late elementary, the square root of 4 was 2. Well, they kind of lied to you. The square root of 4 is actually +2 and -2. Because 2 times 2 is equal to 4. And negative 2 times negative 2 is equal to 4. But the reason they didn't tell you that is because it didn't really matter back then. But when you solve for a variable, you always have to take the positive and negative. So if I just say, like, what's the square root of 36? 6 is okay. But if I'm saying x squared is equal to 36, you can't just tell me x equals 6. You also have to tell me x is equal to negative 6, because both numbers work in the actual problem. So if we take a look at this now, x minus 3 is equal to plus minus 2. We go, okay, how do I get rid of this minus 3? Well, I add 3. But I'm adding 3 not just to 2, but I'm adding 3 to a negative 2. So I'm going to write, to show all of my work, that it's going to be 2 plus 3 and negative 2 plus 3. Well, 2 plus 3 is equal to 1. Got ahead of myself. 2 plus 3 is equal to 5. And negative 2 plus 3 is equal to 1. So those are your x-intercepts. So now let's graph it. And this is just a rough sketch. So we have our vertex at 3, negative 4, which is right around here. We have our y-intercept at 0, 5, right up here. We have our x-intercepts at 5 and positive 1, so 1. So you got the left-hand side settled. But the problem with the right-hand side is you've only got two points. So all you could do would be make a straight line, which isn't going to be good. So you have to have that third point to make you guide it with that curve. That's why we love that these are symmetrical. So we put in our axis of symmetry. So do you see how this number of point is 1, 2, 3 away from the axis of symmetry? So we have to have another point 1, 2, 3 away, which puts you right here. So it's at the same level, which means it's a y value of 5, and it's 3 away from 3, which means you're at 6. And so then and again, my graphs are always awful because I can't draw curves at all, but as long as I see your 5 points, you're good to go. Alright, now we're on to just solving for variables. Number 5, we have v squared equals 81. So there's no mix of variables, which means no factor ring involved. So how do we undo squaring? We square root. When we solve for variables, we can't just take the positive square root. We have to take the positive and the negative, because 9 times 9 is equal to 81, as well as negative 9 times negative 9 is equal to 81. We have j squared minus 2j minus 35 is equal to 0. This is question number 6. So I look at this and I go, wait, j squareds as well as j's, that means we have a mix of variables, which means you always factor if possible. So this is set up for the diamond, because you have a second degree trinomial. So what adds to give you a negative 2, but multiplies to give you a negative 35. And for those of you who use the diamond, this is what your diamond looks like. So I could use a negative 7 and a positive 5. They add for negative 2, multiply for negative 5. So we have j minus 7 times j plus 5 is equal to 0. Well, if you multiply numbers and you get 0, that means something had to be 0. So either j minus 7 was your 0, or j plus 5 was your 0. Well, if j minus 7 was your 0, then j would have been equal to a 7. If j plus 5 was your 0, then j would have been equal to your negative 5, and those are your two answers, 7 and negative 5. Well, how do I know those are the right answers? So I finished my test. I've got 10 minutes left before I have to turn it in to Mr. Peterson. So what do? Well, I take this number 7, I just plug it in, make sure it works. And I've got a calculator, which is great. So this is j squared, so that's 7 squared minus 2 times j, which is 7, minus 35. So that's 49 minus 14 minus 35. Well, 49 minus 14 is 35. 35 minus 35 equals 0. Oh, great, because that's what we were supposed to end up with when we were done, a 0. And then you would put negative 5 into the exact same problem and make sure you end up with 0 as well. So you can check these answers a lot before you turn them in. Number 7, we have 4c squared plus 20 equals 11. So I look at the setup. I have c squares and just c squareds. That means there's no mix. No mix of variables means no factor. Ring involved. So let's play the game of opposites. How do you get rid of a plus 20? You subtract 20. Alright? How do you get rid of a 4 that's a multiplier? You divide by 4. How do we undo squaring? We do the opposite, which is the square root. And this is where we have a problem, because you're taking the square root of a negative. Square root means a number times itself. So if you have a positive times a positive, you always get a positive. If you have a negative times a negative, you always get a positive. So you can't multiply a number times a number to get a negative number. It's impossible unless you have imaginary numbers, which you learn about in Algebra 2. So for this, we say that the answer is no real solution. Alright, number 8. We have 3x squared plus 5x minus 10 equals 0. So I see that we have a mix, which means we need to factor. So I look for the GCF, don't have one. I look for a factor by grouping. Well, we've got 1, 2, 3 terms, so that doesn't work. I look for the diamond. Ooh, we can do a diamond, but we've got that number in front, the 3. So we have to use that and multiply that by the negative 10. So what still adds to give you 5 and multiplies to give you a negative 30? Well, it doesn't work. There aren't any integers that will multiply to give you that negative 30 and add to give you 5. So when you have that situation, we usually use the quadratic formula, which you do, unfortunately, have to have memorized by Friday, which is negative b plus minus square root b squared minus 4ac all over 2a. And remember, if you know the quadratic formula, that means you already have the vertex formula. So this one formula is actually going to help you out with 2 formulas. So let's put it down. So a is equal to 3, b is equal to 5, c is equal to negative 10. So let's plug it in. negative b. So negative 5 plus minus square root b squared, which is 5 squared, minus 4 times a, which is 3, times c, which is negative 10, all over 2a, which is 2 times 3. So now we use Jim does. We do everything in the grouping symbol, which we also refer to as the discriminant in the quadratic formula. We do that first. So we do 5 squared, which is 25, minus 4 times 3 times negative 10. And I like to do all this at one time. So negative 4 times 3 times negative 10. That's 12. Negative 12, sorry, times negative 10, which is 120. Now that's a positive 120. So that means I'm going to add it to the 25. If it would have been a negative 120, I would have subtracted it from the 25. And 25 plus 120 is 145. So we've got what's underneath the square root. So we had the negative 5 outside. We got a 145 under, and we've got a 2 times 3, which is a 6. So all you do now is know how to use your calculator. You do negative 5 plus 145 divided by 6, which is approximately 1.2. And then you do negative 5 minus the square root of 145 divided by 6, which is approximately negative 2.8. Now, if you aren't getting those numbers on your calculator, make sure you see me before we take the test on Friday. Number 9, x squared plus 11 equals negative 12x. So I take a look. I've got x squareds and x's, which means I am mixing, which means I need to factor. But before you factor, the equation has to equal 0. So what do we do to make a 0 over here? We get rid of that 12x by adding a 12x. Negative 12x plus 12x is a 0. We do it to the other side as well. Now let's make sure we put these in the right order. X squared is the most important because it has 2 x's. 12x is the next most important because it has 1 x. And then the 11 is the least important because it doesn't have any variables whatsoever. So now we hope that we can factor this. Well, it's set up as x squared x number, which means we can use the diamond. So it adds to give you 12, but multiplies to give you a 11. Well, there's only one thing that multiplies to give you an 11, a 1 in 11. And if we look, they had to give you 12 too, which is great. So x plus 1 times x plus 11, which is equal to 0. So this number times this number is equal to a 0, which means something had to be 0. So either x plus 1 had to be 0, or x plus 11 had to be 0. So now solve for x. X equals negative 1, x equals negative 11. Number 10, we have h plus 9, 2h minus 5, and h minus 321 is equal to 0. So we look, no mix, which means no factor. So now let's take a look. It says this times that times this is equal to 0. So something had to be 0. So maybe the h plus 9 was 0. Or maybe the 2h minus 5 was 0. Or maybe the h minus 321 was 0. So let's figure all these out. So if h plus 9 was 0, that means h was negative 9. If 2h minus 5 was 0, that means h was equal to 5 halves. If h minus 321 was your 0, h was equal to 321. So all three options are viable, which means you have to give all of them as an answer. Okay, we have x squared plus 8x plus something, and they're asking us to make a perfect square trinomial. Well, remember, perfect square trinomials mean that the first term and the last term are perfect squares. And the middle term is twice the first square root times the second square root. So what we've realized, we've talked about in class, that if you're looking for this number, you take the middle number, you divide it by 2, and you square it. So in this case, the middle number is 8 divided by 2 squared, which is 4 divided by 2 squared, which is 16. Now how do I know I'm right? Well, let's take a look. The first term is x squared. The last term is 16, which we figured out. And the middle one is an 8x. So let's make sure. The square root of x squared is x. The square root of 16 is a 4. The middle term has to be double their square roots. Well, x times 4 doubled, it's an 8x, which is exactly what they had. So we know it is correct. Number 12, same thing, v squared minus 18v plus blank. Well, we're going to take that middle term, which is here, we're going to divide it by 2, and then square it. So 18 divided by 2 is 9. 9 squared is equal to 81, which is our perfect square trinomial. 13. So this says solve it by completing the square using the quadratic formula. So if you're a quadratic formula person, which I will not do because it's the longest way possible, the first thing you would have to do is make this equal to 0. So you would have x squared minus 6x minus 19 equals 0, which means a equals 1, b equals negative 6, c equals negative 19, and you have to do negative b plus minus square root b squared minus 4ac all over 2a. I'm not going to do any of that because it takes way too long. But if that's what you are comfortable with on Friday, please by all means do the quadratic formula. What I'm going to do instead is I'm going to complete the square. So this is going to be x squared minus 6x plus a blank equals 19 plus a blank. I want to put a number in here that I can factor easily. So if I take the middle term, which is 6, divide it by 2, and I square it, I get a 9. I'm going to put that right here. Now since I put a 9 on the left-hand side, I have to put a 9 on the right-hand side. So now let's take a look at what we've got. I've got x squared minus 6x plus 9 equals 28. See, now I can factor this. Because perfect square trinomials, when you complete the square, you've made this great perfect square trinomial. All you do is take the square roots. So x, 3, put your squared, minus sign, drop it down, equals 28. Now you can play the game of opposites. To undo squaring, you take the square root, So x minus 3 equals plus minus the square root of 28. To get rid of a minus 3, you add 3. So x is equal to square root 28 plus 3, and x is equal to negative square root 28 plus 3. And now you go to your calculator, which gives you 8.3 and negative 2.3, which is what you would have received from your quadratic formula, which is fine, but I'm always going to show you the most efficient way of doing something. Alright, number 14, so we're getting close to being done. F of x equals x squared plus 12x minus 32. So we are currently in standard form, but the question wants us to go to vertex form, which is f of x equals a x minus h squared plus k. And the vertex are the coordinates h comma k. So here's all what we got to do. We've got a formula for the vertex. Vertex is negative b over 2a. Well, the b value is 12, so we do negative 12, because negative b over 2 times a. The a value is a 1. Negative 12 over 2 is a 6. So I have f of x equals a. The x value is a 6, but we use the opposite, so it's x minus 6 squared plus whatever k is. Well, k is the y value. Well, if you know the x and you want the y, you plug it in. So we have f of 6 equals 6 squared plus 12 times 6 minus 32. Actually, you know what? And this is what I get for doing this late at night and being sick at the same time. I'm sorry. So no, you cannot get a brick during class. This should be a negative 6, which means you have f of x equals a x. The opposite of negative 6 is plus 6 squared plus k, which is going to be the y value. So to get the y value when we know the x, we're going to plug negative 6 into the problem. So f of negative 6, is going to give me negative 6 squared plus 12 times negative 6 minus 32. So negative 6 squared is 36. 12 times negative 6 is going to give me a negative. 12 times 6, 6 times 2 is 12, carry the 1, 72, so 36 minus 72 minus 32. 36 minus 72 means we're going to do 72 minus 36, which gives you a negative 36. Negative 36 minus 32 is a negative 68, and that is your y value. So your vertex was located at negative 6 comma negative 68. But in vertex form, again, let me write it down, a x minus h squared plus k. You use the opposite of the x value. So you now have y equals x plus 6 squared. You use the exact k value, that's why they put a plus sign. So you had a minus 68, so you put in a minus 68. And your a value, don't worry, we identified that already. The a value is a equals 1. So if you want to put a 1 in front, great. If you don't want to put a 1 there, you don't have to. So this would be your final answer, except in function notation, we say f of x equals x plus 6 squared minus 68. Okay, question 15, the discriminant. So I'm going to give you all the different varieties. The discriminant is the b squared minus 4ac, and it's under a square root sign. So if you do this whole thing and you get a positive number, that means there are two solutions. Just like we proved earlier, 3 times 3 equals 9, but negative 3 times negative 3 equals 9. So when I say what's the square root of 9, it's not 3, it's positive 3 and negative 3. If you get a negative under the discriminant, there are no real solutions, because a positive times a positive is a positive, a negative times a negative is a positive. So if you multiply two identical numbers, you're always going to get a positive. And the last scenario is, well, what if you get a 0? Well, the square root of 0 is equal to 0. Positive 0 and negative 0 are the exact same thing, which means you only have one solution. Number 16. You've got your picture. You've got a vertex, which is located at 1, 3. So vertex form is y equals ax minus h squared plus k, which is why you want to know this formula, because if you don't know this formula, you don't know this answer whatsoever. Your vertex is located at h, k. So we can get half of the answer, 2/3 of the answer done right away. So y equals, I have no idea what a is, so I'm going to put a. I do know what the x coordinate is of the vertex. It's 1. So I use the opposite. So I use a minus 1. The k is your y value, and it's the exact thing you see. So I see a positive 3, so I put a plus 3. So I have y equals a x minus 1 squared plus 3. Here's our issue. We don't know what the a value is. So what we do is plug in a point. So pick a point from your graph and pick something easy. So on my graph I see that 0, 5 is an easy point to use. So the 5 is your y, 0 is your x. Now you only have one variable, which means you can solve for it. So let's do it. 0 minus 1 is negative 1. Negative 1 times negative 1 is positive 1. 1 times a is just a. Now, to get a by itself, to get rid of a plus 3, you subtract 3. So you get 2 is equal to a. So again, this was the generic formula for vertex form. Well, we already had the x minus 1 squared plus 3. Now we know what a is. A is equal to a 2. So this is your final answer. 17. You have an equation. H equals negative 16t squared plus 98. They said how long before the ball hits the ground? Well, if you hit the ground, that means your height is equal to 0. So put 0 in for the height. And now you can solve for the time, which is what they're asking for. So I see t squared. That's all we've got, so there's no mix. So play the game of opposites. How do you get rid of a plus 98? You subtract 98. So negative 98 equals negative 16t squared. The negative 16 is a multiplier, which means to get rid of it, you divide. Negative 98 divided by negative 16 is 6.125. So you're almost done, but you have a t squared. We want a t. The opposite of squaring something is to take the square root, because t times t is t squared. So that's how you just get the t by itself. And here we're going to approximate to the nearest tenth, which you put that on your calculator and you get 2.5. And the last ones. These are the exact same rules that we use with absolute value as well as your function shifts. X plus 5 squared. This plus 5 is with the x. X's control horizontal movement because the x-axis is horizontal. The word horizontal has the letter O. O for opposite. So what you might think would be 5 to the right because you're adding 5, it's actually 5 left. And that's your answer for 18. So I see that there's a number with the x. X is the horizontal, which means it's the opposite. So I see a plus 3, which normally means right 3, because you're adding 3, but we're doing the opposite, so it is left 3. Now the outside number that's not with the x, that's always your vertical motion. Well, vertical has an E in it. E for exactly what you see. So a plus 82, if you're doing things vertically, if I told you to go plus, you would most likely think up, which is exactly what you do, up 82. And last but not least is this negative out in front. That means it flips, but you can't write flips. You have to say reflects. It reflects over the x-axis. I hope this has helped, and this is the end of the study guide video.